Hi everyone. Chalo. Good evening everyone. How are you all? Good evening guys. Welcome back. I am very excited to study a new chapter. Okay, that's good. Stop spamming. Just post it once. Okay, once. Thank you. Ram Ram. Ram Ram. Guys, stop right now. Stop right now. Thank you. Yes, we have completed friction. 97% in ICSE. It's raining, that's why. No, I'm just checking how fast it is raining. Is there a possibility of a rain man relative motion problem to see? Ayawaz. Okay, everyone, I look different without specs. Chalo, that's a compliment I will take. Yes, so congratulations all the ICSE students for finally making it officially to 11 standard. Awesome, everyone. Cool. No audio. Quickly, everyone, give me a feedback. Quickly, give me the feedback, everyone. Quick. No cross chat. Weight machine video. हाँ यार वो नहीं बना. Weight machine का video बनाने. Your audio and video is perfect. Thank you, Satish sir. Sir, it's my birthday. Happy birthday, Akhil. Happy birthday, Akhil Reddy. Okay. Ansh, based on spring, the problems will be solved today in this chapter. Hello, Samarpita. Quickly, everyone, respond to the hotspot. जल्दी. नया chapter शुरू करना है. Sir, did we study impulse? आज impulse का भी idea दे देता हूँ. Load मत लो, tension मत लो. Impulse का idea भी आज दे दूंगा. We have actually studied impulse, but मैंने इसे formally introduce नहीं किया. Okay, sir, we didn't. Sir, did friction on circular motion. Yes, Priyanshu. Who is the master teacher? Who is the master teacher of this class? So who decides what we are studying and when we are studying? First answer my question, then I will answer yours. No, even I don't decide. I've told this a number of times that there is a fixed flow of chapters which is given to us, and in that order we go. You must have seen that every time when we enter in a session, it already tells us the name of the chapter, right? So in work power energy, once we will complete the chapter, I'm assuming after work power energy or in this chapter only we'll study circular motion. And unless we know circular motion, we do not know anything about banking of the road and everything. So do not worry. Okay, everyone. Chalo. Sir, there is a TV behind you. It's actually much bigger than a television. Okay, I have already shared the link of. Actually, I'm switching off the chat now because this has been a long time that I have been clarifying this. So I need to clarify this one more time. First of all, if you can't see or hear me, please rejoin the session. Okay. If you are not able to hear me, if you're not able to see me, please rejoin the session. That is my request to all of you guys. Okay. Now coming to two things. First one, very importantly, I will be talking about. Today I will give you the idea of impulse. That is one small topic. We have studied about it. We have not formally introduced it. So I will introduce it today. Don't worry. If not today, any time in this chapter I will introduce it. You will not have to face any problem. Second thing about vernier caliper and screw gauge. It has been officially brought to me that students are complaining about this part not being done, and I discussed it with the entire physics team, and including obviously the head of the department of physics with Vedantu. So it is officially not done yet in any batch. Okay. Now coming to the part that you guys had Tattva sessions where questions of vernier caliper were done. Those teachers who were taking the sessions were not aware that in the batch which they were taking those sessions, the vernier caliper and screw gauge is not being done. So they assume that it is done. So you guys, for you people, the bottom line, you guys do not have to worry about screw gauge and vernier caliper. It will be done. Okay. So as of now, please keep it. Even in the tests, I have asked them to not keep it unless it is being taught in the batch. Okay, guys. For once and for all. So in future, if anybody is asking this in the chat box, you have to tell them that it will be done later. It is not done anywhere. Okay, everyone. I hope I'm clear. Very well. Fine, everyone. Am I understood now? Let's end the debate of screw gauge and vernier caliper. Tension mat lo. Okay. जितने भी जेई के नॉन फिजिक्स वाले सवाल हैं, all the questions which are not related to the subject or the chapter are to be asked at the end of the session. Okay. Again, Tarush and everyone else, the test syllabus and the other things are being told to you. Okay, are being told to you by not me, but your SAMs and the official people tell you that. Okay. I have not made the weight machine video. This has been the week where JEE examination is going on. It was a very. In fact, I was working yesterday, even on Sunday. Okay. Where are you from, sir? यार आंसर दे दो ना, तुम लोगों को भी तो आंसर पता है. बाकी के लोग इस क्यूरियस बच्चे का आंसर दे दो, बाकी लोगों को पता है. I'm not able to address you by your name. What is your name? Joshua. So to you only, I wanted to tell you that all the questions which are not related to the chapter going on are to be asked at the end of the session. Okay. And second time, if you will spam like this, I will kick you out of the class. Yes. Thank you. So that is my hometown and my current city of residence is Mumbai. Okay. Thank you. Yes. Thank you so much. आज नया चैप्टर स्टार्ट करेंगे या ओल्ड वाला खत्म नहीं हुआ है? तो आज नया चैप्टर स्टार्ट करेंगे, ओल्ड वाला खत्म हो गया है, टेंशन मत लो. ओके कूल. चलो भाई, तो स्टार्ट करते हैं. और स्टार्ट करने से पहले सबको याद होगा कल होमवर्क क्वेश्चन था. लास्ट टाइम आई गिव यू गाइस दीस this question as your homework. And yes, quickly say hi to your class teachers. Thank you so much for reminding me, Nihal. Quickly say hi to your class teachers. We have Satish sir, the awesome Satish sir, and awesome Rishabh sir. Both amazing personalities are class teachers. Okay. Sir, we are not doing pseudo force, centripetal force. पता भी है centripetal force क्या होता है? हाँ? तुम लोग क्लास में आते हो तो पैरेलली मैच करने के लिए आते हो कि सर ये चीज आपने पढ़ाई कि नहीं बुक के साथ पैरेलली क्यों नहीं पढ़ाई आपने? हाँ? मैं नहीं करा रहा pseudo force, मेरी मर्जी. मैं कराऊंगा नहीं pseudo force. कंप्लेंट कर दो. कंप्लेंट. weekend@vedantu.com. Suri sir not teaching. अरे बताइए तो रहा हूँ नहीं पढ़ाऊंगा. That's the response. Okay. आज ये काम करते पढ़ते नहीं है ना. आज का जो भी सिलेबस है तुम पढ़ लेना, स्लाइड्स तो है ना. आज का सिलेबस ऊपर वाले के हाथ में. आज न्यूटन के भरोसे चलते हैं. क्या बोलते हो? गाइडेंस सेशन आज ही कर लेते हैं. चलेगा? ऑलराइट, क्या बात है, बहुत बढ़िया है ना. ऑसम. चलेगा नहीं दौड़ेगा, बहुत बढ़िया. ऑसम. चलो भाई, switching off the chat and let's start the session. और ये क्वेश्चन था guys, this was the question which was given to you people to try in the form of your homework question. As you can see, this is a JEE problem, came in 2019 in JEE main. Okay, and let me explain you what is happening in the question. There is a block whose mass is given to us as 10 kg. It is placed on a rough inclined plane as shown in the figure, right? So already there is a 3 Newton force acting on it. Let me tell you, this 3 Newton force cannot be mg sin theta. It can be, but it is not mg sin theta. So how do you know it is not mg sin theta? Because I can calculate mg sin theta. This is mg sin theta. What is the value of mass? 10. What is the value of g? 10. What is the value of sin 45 degree? 1 by root 2. 20 by root 2 is definitely not equal to 3. So it is an additional force which is given in the question, right, everyone? This is an additional value of the force which is given to be acting on the body. It is trying to pull it downward. Okay. So the coefficient of friction between the plane and the block is given to us as 0.6. Okay. What should be the minimum value of the force that should be applied on the block so that the block just does not move downward? That minimum value is being talked about. So for your reference, I am first showing you the free body diagram which is presently there in the absence of this force P. Okay. So imagine that there is a block which is placed on an inclined surface. So this is the inclined surface on which this body has been placed. And what is happening? The body is going down, and you need to actually check that if the body is going down without the force P being applied on it. So body is basically not holding here. It's actually going down again and again and again. It's not holding. It does not want to stay here. It's just going down again and again. So if we look at the free body diagram, it's the 3 Newton force which is acting down the plane. Along with that, we already know this very well, that mg sin theta is trying to pull the body down. That's the force which brings the body down in the absence of 3 Newton also. Okay, or tries to at least. Then we have normal force which is trying to counterbalance mg cos theta and is balancing also, because your body is not moving along this direction. If I define the coordinate axis, then the body is moving along x-axis, the new x-axis. It's not moving along y-axis. So definitely along y-axis, the normal force is balancing mg cos theta. Perfect. So if say the body is not experiencing any force P, I'm not applying any force P on the body. So my question to all of you guys, the direction of friction, because I have not drawn that force yet, so you have to tell me the direction of force of friction on the body in the given scenario right now, in the absence of this force, the direction of the friction will be along mg sin theta, means down the plane, or opposite to mg sin theta. Tell me everyone in the chat box. The friction will be acting along mg sin theta or opposite to it. Definitely will try to stop it, right? Mg sin theta will try to stop it. So if it will try to stop it, it will have to act opposite to mg sin theta. Thank you for telling me that, everyone. So this is the direction in which your friction force is acting. But the problem is the friction is not able to stop the body. The friction is not able to stop the body. If you want, you can check it also. That is an exercise that you can try by calculating mu into mg cos theta. When you will check this value, definitely mg cos theta and mg sin theta for theta value 45 degree comes out to be same, because sin 45 and cos 45 values are same. Right, everyone? So currently, when I look at the situation, I find out that if I multiply mg cos theta by mu, which is a value less than 1, means if I multiply that value by 0.6, I'm actually reducing the value. So friction is actually less than mg sin theta. And you are adding a 3 Newton force along with that. So definitely my body is not going to hold there. Even the friction will not be able to stop the body. So can I say that you need a force to help the force of friction? Yes or no, everyone? We need a force P to help the force of friction, right? And if I'm talking about the minimum value of the force P, I need to apply minimum value. My efforts that I'm going to apply to stop the body are minimum. So can I say the force of friction has to do its maximum job? उसे अपना maximum support देना है. So what is the nature of the force of friction in that case? What is the nature of the force of friction? Can I say limiting friction will be acting for sure? That's it. Problem done. Problem done. After this, only mathematics. So this is the free body diagram, everyone. This is the free body diagram. You're all able to see this. 3 Newton acting along with mg sin theta, trying to pull the body down. P and limiting friction are helping out to stop the body and to keep it stationary. So can I say that along this new x-axis, the net force acting on the body should be equal to 0? Sigma fx should be equal to 0. Definitely sigma fy is also 0. Means no doubt n is equal to mg cos theta. So any which way hai, that is any which way there. But what else is there? P plus limiting friction should be equal to mg sin 45 degree plus 3. Are you guys getting it? Okay, after this only mathematics. I'll show you the mathematics directly now. Have a look. So P plus FL. I did not write FL. So I wrote it. P plus FL I wrote. So P plus FL is equal to 3 plus mg sin theta. Take this FL to the right hand side. You will have 3 plus mg sin theta minus friction limiting value, that is mu n. And n value is mg cos 45, which is mg by root 2. Put it here. 3 plus mg sin 45 degree minus mu into mg cos 45 degree. Simplify that further. In this, if you take mg by root 2 common, if you take mg by root 2 out of the bracket, you'll be left with 1 minus 0.6. 1 minus 0.6. That value is 0.4. And that is what is written here. Okay. 0.4 can be written as 4 by 10, mass is 10, g is 10, root 2 rationalized becomes root 2 by 2. You further simplify it. You guys are very good at mathematics, at least calculations. So simplification will give you the value as 31.2. The nearest option that we have in the question is 32 Newton. Okay. So this is the solution. Okay, everyone. Now, because we are trying to wrap up laws of motion and friction, I will give you the idea of impulse right away. Okay. The part which I formally did not introduce earlier. So everyone, okay, impulse is Okay, it is the impact of force when it acts for a very short duration of time. Impulse is called the impact of force when the force acts for a very short duration of time. Like, I'll give you a very simple idea. You must have seen that all these cutleries or all these crockery items, whenever you purchase it, as in you don't purchase it, whenever it comes in your house, the new cutleries or the new, these bone china, all these utensils or anything you call it. So whenever these cups and all these trays come, they are usually given a good packing. Very good packing would be thermocol. If not that, then at least paper packing is given to it. Why is it so? Is basically that if at all any sudden force acts on it, any sudden force, then there are chances that it may break. That sudden force is basically force acting for a very short duration of time. Means what? If you hold this cup, and you apply force on it, I'm applying force on it. So if I'm applying force on it, it's not going to break that easily. It's not going to break that easily. It can break, no doubt, but it is not going to break that easily, right? It's not at risk, in simple words. But you just drop it. Just drop it. It is going to have impact only for a very small fraction of time, and it is definitely going to break. So what's the difference here? So everyone, the story actually goes to the second law of motion. We all remember that the second law of motion states that the external force acting on a body is equal to the rate of change of momentum. Which means what? The magnitude of the force is not only dependent upon the change in momentum, it is also dependent upon the time taken by the system to change the momentum. I'll give you a very simple example once again numerically. Say we have a car and there are passengers sitting in it. It is going in this direction, and say right now its speed is say 10 meters per second. Okay, realistically I'm keeping it 10 meters per second. Actually, car can go faster than that. Say we call it 10 meters per second, and this 10 meters per second car, when it is suddenly sees a signal here, the driver applies the brake and the car stops. When the car stops, its velocity changes from v equal to 10 meters per second to 0, and this happens in a time gap of say 0.01 second. Means what? Suddenly somebody came in front, or suddenly the signal became red, and the driver applied the brake suddenly. Okay, so this is one situation. Second situation is also of the same car, with people in the car moving with 10 meters per second. And after, in fact, let me just make it a little interesting by saying that here someone came in front, so the brakes were applied, and here simply the signal got red, so you applied the brake, the usual process which is done by the driver of the car, and maybe by taking a good amount of say 5 seconds. You saw the signal is getting red, so you took your good 5 seconds. Okay, there is a signal coming, it is red, let's stop the car. Okay, everyone, in which situation the chances of people getting hurt are more, or are definitely there? Situation 1 or situation 2? Where do you think the people inside the car will be hurt? Tell me. Definitely 1, no doubt about that. But you see that the change in momentum in both the situations is the same. Have a look at this, guys. If we say that the car has a mass of 100 kg, actually it is 1000 kg. Okay, so if I look at situation 1 and I calculate the change in momentum in situation number 1, so the mass of the car is m, whatever be the mass. The change in the velocity is 10 minus 0, magnitude only, the change in velocity. It comes out to be 10 m, right, everyone? Cool. And if I write the mass also, so this comes out to be 10,000 units. Okay, and if we calculate the change in momentum in the second situation, does it also come out to be same? Will the change in momentum come out to be same as the first situation, everyone? The car's velocity goes from 10 to 0 only in both the cases, but the game is actually defined by the time now. Now look at the difference. Look at the difference in the force. In the first situation, we have 10,000 change in the momentum, and the time taken is 0.01. This comes out to be already 10 to the power 4 multiplied by 100, comes out to be 100 into 10 to the power 4 Newton force. Okay, F2 comes out to be same amount of change in momentum, but the time taken is 5. Okay, for simplistic understanding purpose, I'm taking the time to be 10 seconds so that we are able to correlate it better. Okay, so everyone, the time taken is say 10 seconds. So what do we see here? The value. This comes out to be 0.1 into 10 to the power 4. Or we can say it is 10 to the power 3, and this is 1000 into 10 to the power 3 Newton. So guys, what you are seeing here, that F1 is 1000 times F2. You see that this value is 1000 times 10 to the power 3, and this is 10 to the power 3. Are you guys getting it? Everyone, are you guys getting it? What is happening? The same amount of change in momentum. The same amount of change in momentum is bringing different amount of force acting on the bodies, right? What does this mean? What does this mean? This means the difference is actually of the time which is taken in order to change the momentum. Okay, everyone. Ball catching situation. I told you that I've already given you the understanding, but I did not formally introduce this concept. So what is impulse? Mathematically, you write impulse as the force multiplied by the short duration of time that it is acting for. This is called as impulse. And guys, if you will see clearly from here, what will you say F into delta t is? What will you say F into delta t is? Can I say it is nothing but change in momentum only? Right, everyone? It is change in momentum, not momentum. It is change in momentum. Don't call it change in. Don't call it momentum. It is change in momentum. Okay. Are we clear now? This is what basically impulse is. Okay. Cool. Okay. So if you have still any doubts about this topic, please keep them noted. I will take it towards the end of the session because we are already halfway. 1/4 of the session time is gone. We are yet to start the chapter. Okay, everyone. Please keep the doubts noted and ask me towards the end of the session. Chalo, bahut badhiya. So guys, we are now moving towards something which is a landmark in itself. Yes, I told you people when we started officially physics with kinematics. Yes, before that we studied a lot of mathematics. We studied vectors, we studied calculus, differentiation, integration, and whatnot. And formally we started our physics with kinematics, I can say. Or we started kinematics, but we took a break in between. Right? Point is, first we studied kinematics, where we were not concerned about the reason behind the motion. Then we started our discussion about laws of motion and friction, where we started concerning ourselves with the reason behind the motion. Right? And I told you that in this universe of mechanics, in this entire unit of mechanics, force is the most important quantity. Right? You by now have already kind of seen the trailer of it, and as the movie will go forward, you will realize force is the most important quantity because entire mechanics will revolve around it. Okay. Second important quantity is now getting introduced, or second important chapter, and the quantity, energy, work or energy, both are now going to get introduced. Okay. So the first set of laws are already being seen by you people. The 3 laws of motion. You collectively call them laws of motion. Remember, this entire story of mechanics is the unit that you are studying in 11th standard. Okay, there are only two units that you study in 11th standard. First one is called mechanics, second one is called thermodynamics or thermal physics. Thermal physics will be only the 20% of 11th standard. 80% of 11th standard syllabus is mechanics. Okay, and that 80% syllabus has only three laws. The first one you have already studied, the three laws of motion. Second law will get introduced here, which you already know from 5th standard. The law is something that you already know. You will see its application in this chapter. Okay, hope you people have heard about law of conservation of energy, right? Everyone has heard about that law of conservation of energy, right? So out of three most important laws, you have three means collection of laws. Laws of motion seen, law of conservation of energy is not something which is new for us. Okay, yes. So this is what the chapter will revolve around. That is why energy will be the second most important quantity for us. Everyone, ठीक है, हमारे time पे 5th में बता दिया था, तुम्हारे time पे 6th में बताया होगा. So relax. हाँ. So what is that we are studying today? We are only going to speak about the first quantity today, and that is work. Okay. I hope you people have fresh memories of dot product. Okay, everyone. सबको dot product याद है हल्का हल्का? Everybody remembers the dot product? नहीं याद है तो रिवाइज कर लेना क्लास के बाद में. Absolutely. So what is the story of today? Today we'll be speaking about quantity work, then we'll speak about work done by various forces. Rather, we'll first speak about work done by constant force, then we'll speak about work done by variable force, and then we will speak about work done by different types of forces. Okay, so everyone, let's start the session. So let me first bring the entire thought that why the discussion of work is required. If we study a situation where there is a skater or a skier, and that person or their object is moving down the inclined plane, okay, and maybe there is friction, maybe there is no friction, does not matter. We already know the acceleration down the inclined plane. If it is smooth, it is g sin theta. If it is not smooth, it is g sin theta minus mu g cos theta, the acceleration of a body coming down an inclined plane. So if we want to calculate, say, the speed at the bottom, that's what the situation is mentioning here, right? So if we want to find out that if a person starts to move with a zero velocity from here, with what velocity this person or this object is going to reach the bottom of the inclined plane, if we already know the length of the inclined plane, if we know after traveling for a certain length, for how much velocity, with how much velocity the object is going to reach the bottom of the inclined plane. So we can definitely find it out by laws of motion, because we already know the acceleration value. Say, assuming there is no friction, if I consider it to be g sin theta, if not, then this will also get added in this equation. So maybe this is your acceleration. You know that this value will be a constant for a given value of mu. You already know that u value is 0. So if you want to find out velocity, you can also find out it by v square equal to u square plus 2as, and s given as L here. U is already 0. So it's not difficult. We can definitely find out. We don't need anything else. We already have the sufficient information, right? Important thing to notice is that here the acceleration depends on the inclination angle theta of the inclined plane. Okay? Yeah. Suri sir को correct करने में जो मजा है ना, मतलब वो physics सीखने में नहीं है. I have seen that in many students, right? So if the situation is this, when the inclined plane has a constant slope, the situation is actually very simple. But you know that when we travel on the roads don't have a constant slope. Their slope keeps on changing. So if slope is continuously changing, guys, then the problem is, if I'm somewhere here, the inclination is different. If I'm here, the inclination is different. If I'm here, the inclination is different. Which means what? Here inclination is theta 1, here the inclination is theta 2, and maybe here the inclination is theta 3. And like that, the inclination is continuously changing. Not that only three angle values are there. There are multiple angle values changing as the body starts to move from point A and comes down to point B. अब क्या करें? So definitely the situation becomes very tricky. You can see that now finding the value of acceleration itself is a problem, because acceleration will not be a constant anymore. Because if you will try to write it as a equal to g sin theta minus mu g cos theta, then the value of theta itself is not constant. If theta is not constant, then a is not constant. If a is not constant, how do I find out the value of acceleration? And if not, how do I find out the value of the overall velocity? Are you getting this? That situation is becoming complicated, and this is where we can say that this is not the only case. There will be multiple situations where we'll find out that calculating acceleration and effectively calculating the force acting on the body is not that simple every time. And that is where the chapter of work by energy comes into existence. Means I want you people to make a mental note of this point, that wherever acceleration of the body is not constant, wherever the body which is moving is having a variable acceleration. Means story, if I have to take it back to kinematics, it started with types of motion: uniform motion, non-uniform motion. In non-uniform motion, there were two further categories: uniformly accelerated motion, non-uniformly accelerated motion. So this non-uniformly accelerated motion is the one where calculus comes into existence. So whenever this non-uniformly accelerated motion happens, we basically try to refrain. We basically try to avoid using laws of motion to solve the problem. Not that laws of motion are not applicable there; they are applicable, but mathematically very complicated situations will be seen there. You will see that wherever the acceleration is not going to be constant, if we try to take the approach from law of conservation of energy or methods which involve work and energy, situations will be very easy for us to tackle. Okay, so mental note of this point. Next one, it says that these powerful concepts enable us to the shortcut and detailed application of laws of motion and analyze more complex situations. The same thing that has been said here. So guys, we begin the concept of work. Though today you will still not get the entire picture clear that how the complicated situations which we are talking about will be solved unless we are done with defining the energies also. So today's discussion will only revolve around work. So we will first, today's today's discussion and session is more about an introductory session of work. Okay, everyone. So what exactly is work? Something which is not very new for us. We already know this from our earlier classes, 10th standard, that whenever there is an object on which a force is acting and say the body is displaced, then definitely that force is doing some work, and mathematically you already know that how we calculate that work. This is how. I was not demonstrating. I was telling you to see the screen. Okay, so yes, we say that the work done is written as a dot product of force and displacement. Okay, everyone. ये सबको याद है? अगर नहीं याद है तो तुमने वो चैप्टर या तो मेरे साथ नहीं पढ़ा है या फिर तुमने रिवीजन नहीं किया है. ये याद आया सबको? Okay. So work done is the dot product of force and displacement. Remember this part. Remember, if dot product is done, dot product is also called as scalar product. Remember, dot product is also called as scalar product. And why it is called scalar product? Because you are multiplying two vector quantities, but the output that you are getting is a scalar quantity. The output that you are getting is a scalar quantity. So this is a scalar quantity for sure. Here is a mistake in the next line. Here is a mistake in the next line here. Can you figure out the mistake, everyone? The unit of work is not Newton meter. It's technically Newton meter, but it is, or I should say, it looks like Newton meter, but it is not correct. I deliberately kept it there, No, it is force into displacement. It is Newton into meter only. If you will go to find out the dimensions, yes, it is Newton into meter. But in your life, you will never say that work and energy have units Newton meter. I will give you the answer of this question in a chapter called as rotation motion. I will not forget that. Don't worry. I will give you the answer. Okay, everyone. As of now, please remember work and energy's unit is not called Newton meter. It is called joules. Okay. There is a quantity that we will study in rotation motion called as torque. That quantity has unit of Newton meter. Okay. That quantity has a unit of Newton meter, and it is only to differentiate between the nature of these two quantities that we do that. Same dimensions, yes. Same dimensions, but different units. Remember this as an example. We'll have better explanation in that chapter. उससे पहले कोई तुम्हें परेशान नहीं करेगा इस particular point पे. ठीक है? Om Durge, you are on the verge of getting blocked. Om Durge. Okay? Cool, everyone. So switching off the chart so that we all focus once again. Dimensions m1 l2 t minus 2. Now, what I'm now about to explain you is something which you should pay very good attention to. Okay? So everyone, when you were studying this part that work done is calculated as force into displacement, then there was an inherent assumption which was made by the textbook in 10th standard. The inherent assumption was that the angle between force and displacement is always 0 degree. But you know that it is not necessary that always the angle between force and displacement is 0 degree. Definitely not. The best example is whenever you travel with those trolley bags, those suitcases, and those suitcases have those handles. You are applying the force not horizontally. In those suitcases, you apply the force like this, but the suitcase moves horizontally. So definitely the force that you apply is not always at 0 degree angle. But was the textbook wrong in the 10th standard? No, it was not wrong, or not entirely wrong. It was more based upon the limited information that you had till 10th standard. You know that you did not learn vectors till 11th standard, right? So now that you have learned that chapter, so the entire understanding has to be given to you people. Okay, so this is our situation practically, which we want to understand better. So what is happening? You have your force, which is making an angle theta with the direction of displacement. It is not with horizontal. Remember, the angle theta is not always it is not the angle between force and horizontal. Theta is the angle between force and displacement, the two vectors. Okay, theta is the angle between two vectors, force and displacement. So everybody, pay attention to this part. From here, for next 10 minutes, I want your absolute attention on the screen. So everybody will try to resolve our force into two directions. One along the direction of displacement, and one along the direction that is perpendicular to the displacement. Okay, everyone. So this is the diagram which I'm keeping here, and I'm taking it parallelly so that you understand what is happening. Okay, so the same diagram, and in the second diagram, I'm going to resolve. So this is one of the components. This is the other component. Let's call this component F parallel, and let's call this component F perpendicular. Fine, everyone. And whenever we do this, we are basically replacing our main vector by these two vectors, right, everyone? This is called the resolution of the vectors. Now, if that resolution is already done, I can draw the diagram without capital F force. Okay, means what? Now I don't need this. Now I don't need this. I only need my two components. One of the component is this F parallel. The other component is this F perpendicular. This is what it means to resolve a vector. You basically are replacing your single vector F with its two components. One is along, say, the direction of displacement, other one perpendicular to it. So everyone, F parallel, sine or cos component, quickly. F parallel, sine or cos? It is cos, right? So F cos theta. And this is F sine theta. Perfect. Very good, everyone. Awesome. So, awesome. Very good. Now see the magic. Let's calculate the work done by the parallel component. Okay, I'm writing it as this. Okay, so F parallel, the work which will be done. Achha, you will see that the angle between F parallel and displacement is 0 degree. So F parallel into displacement into cos of 0 degree. That's the definition, right? So F parallel is how much? It is F cos theta. How much is displacement? S, and cos 0 is 1. This comes out to be Fs cos of theta. The work done by the parallel component of the force. Parallel means parallel to displacement. Okay. Now calculate the work done by the perpendicular component. So F perpendicular, displacement, and angle is cos of 90 degree, and the work done by that component of the force comes out to be 0. So work total comes out to be equal to work by the parallel component, and that is equal to Fs cos theta. Doesn't look like an extraordinary story so far, but the conclusion will be extraordinary. Conclusion is, whenever you have a force which is not acting along the direction of displacement, making any angle theta with the displacement, listen to me very carefully. Only that component of the force which is along the line of displacement, only that component of the force which is along the direction of the displacement will do the work. The component which is perpendicular to the force, perpendicular to the displacement, is useless, will not do any work at all. And that is why when you have to move your bed, the heavy bed, you basically try to go as horizontal as you can. You try to push the bed as horizontally as you can, because you do not want the efforts of yours to go waste. If you will apply the force at an angle, F sin theta will be the waste component, will not do any work. Are you guys getting it? You always try to apply force as much possible as horizontal, so that your efforts are resulting in work, not getting wasted. Good. Cool, everyone. This is what is the explanation of force with dot product of displacement coming and giving it to be equal to the work. Okay. What do I write it? I'm not writing anything. You write it. I'm giving you the story. It's there in front of you. Okay. Or what you have to remember though is that only the component of force which is parallel to displacement does the work. Okay. याद रहेगा? नहीं रहेगा तो इसे देख लेना हर बार. जैसे ये ध्यान में रखने वाली बात है, लिखने वाली बात नहीं है. Okay. Yep, thank you. So चलो अब फॉर्मूले आगे जाते हैं. Yes, Shivansh. Hey, body what? Then F sin theta component is not the force responsible for it. There are more forces acting in that direction. And by the way, then the displacement will not be horizontal. Then the body will have displacement like this. So the angle will no more be 90 degree between F sin theta and displacement. So the F sin theta direction will change. I'll give you a better example. When the car moves on the horizontal surface, mg does not do any work. But if the car is doing this, then mg sin theta will do the work. The weight is doing the work in that case. We will see the situation in this chapter once again. Okay. So I hope everything is clear to everyone. The displacement direction is important. So now, based upon this, there are three possibilities. The work can be positive, the work can be negative, the work can be zero also. So when will I say that for a given magnitude of force and displacement, the work will be positive? You know that this quantity will come out to be positive only when cos theta is positive. And for cos theta to be positive, the angle has to be less than 90 degree. We know this from mathematics very well, which simply means what? The angle has to be acute angle. Okay. So if the angle between force and displacement is less than 90 degree, the work done will definitely be positive mathematically. What does it physically mean is something that I will give you the idea in the next class, because for that we need to know certain type of energies. Okay. Though it has given a brief idea that positive work signifies that external force is favoring the motion of the body, means what the force is trying to drive the body. That's it. More better understanding will be given to you in the next session. But as of now, yes, in this case, because the force will have the component along the direction of displacement, that is f cos theta. So definitely the force is helping the body go along the direction of displacement, right? So this is why work is positive. When will I say that the work is positive? Whenever the force and the displacement are either making 0 degree angle or any angle less than 90 degrees. So like if you lift any object, if you're lifting any object, the force that is applied by me, is upward, and the body's motion is also upward. So in this case, the force that I am applying and the displacement, both of them are in the same direction. So theta is 0 degree, work done is positive. Okay, we'll speak about what mg is doing in this situation in the next part. Okay, in this part only. So if I speak about work done being negative, so for that, by now you must have guessed it, work done will come out to be negative when the angle between force and displacement is an obtuse angle. Okay, so if the angle between both of them is 90 degree beyond, not equal to 90 degree. Okay, so this is obtuse angle. So if the angle is obtuse, the value of cos theta will come out to be, obviously the angle can be only between 0 and 180. Remember, it cannot be more than 180 degree. Why? Because if the force goes beyond that angle like this, then you will not look at this angle. Then you will start looking at this angle. Okay, everyone? Is that clear? Repeating it once again for all of you guys. If your force starts to act in this direction, like this, so you will not look at this angle as the angle of the force and displacement. That is useless after that. The angle is now this. Okay, remember this point. That angle can be only between 0 and 180. So what does this mean? If you now resolve the force along two directions, you will find out that this is f cos theta, okay, and this will be f sin theta. Or forget about f cos theta, f sin theta. Let's not even say they are f cos theta and f sin theta. You can always find out their magnitudes. Let's call it f perpendicular and f parallel. You can see that f parallel is going to do the work, and that is going to do negative work. F perpendicular cannot do any work at all. So this force is acting opposite to the direction of displacement of the body, right? Everyone, you see that? If this is the body is moving to the x-axis right side, and the force f parallel is acting opposite. So definitely the body's motion is not favored, rather it is trying to stop the body. It is opposing. So what does negative work means? It means that the body is being opposed by the force which is acting on it. And that was happening in this case, by the way. If we talk about the similar situation here, okay, if I talk about the similar situation for the negative work, then I will say that when we lift the body up, then work done by mg is negative. Okay, work done by mg will be negative. How? I'll show it to you. So in this case, what is happening? The force which is acting on the body due to gravity is mg, which is acting downward. So the displacement is acting upward, but mg is downward. And that is why the theta becomes 180 degree, and cos 180 degree value will be negative, -1. Okay, so the work which is done by the gravity does not want the body to go up. That is what it signifies. The gravity does not want the body to go up. It always opposes the motion of a body when it tries to go up. Okay, hope it is making sense. Another possible option is, or example is, whenever a body tries to move, the friction will always try to stop it by acting in the opposite direction. So you can see that when a body is trying to slip on the ground, the body will always stop. Why? Because friction does not want the body to go in that direction. It will oppose the motion. Negative work will be done. You see that? This F, the red force that you see, is the friction force. Remember, the force that you are seeing in the diagram, the one which is written as FF, is the friction force. Okay, capital F is the driving force that is doing a positive work. Okay, hope it is clear. Next is zero work. Now, what exactly zero work means? Zero work means there is no way this force is displacing the body. So if theta becomes 90 degree, or if force becomes zero, or displacement is zero, means what? Either there is no force acting on the body, work is zero. If the body is not getting displaced, work is zero. If body is displaced, force is also acting, then we'll say that the work done is still zero. Best example for that is, what just happened? Yeah, hope you guys are able to see this. When the car moves, it is displaced. Mg is also acting. Multiple forces are acting, but we are talking about the work which is done by mg. Comes out to be zero on a flat road. Why? Because the angle between force and displacement in this case is zero. Okay, is it understood, everyone? Logically, we'll now get to the problem solving. Okay, but yeah, you will have better understanding. Okay, sir, work is scalar. How negative? Who said that scalars cannot be negative? Did I ever say that scalars can't be negative? Its magnitude cannot be negative. Okay, its magnitude is positive, but being negative, it is indicating something. Okay, Hana, mg is acting downward, body is getting displaced horizontally, the angle between them is 90 degree. If you will calculate the work done, it will be mg, the force, s into s is the displacement, and the angle between them is 90 degree. And what is the value of cos 90, everyone? What is the work done? Is equal to 0. Okay, everyone? Is it now clear to everybody? Those who are having doubts, clear now? Better understanding will come with examples. Okay. Hanna, I just explained your doubt only. I just did the explanation part of the car. Got it? So, सर हाउ स्केलर कैन बी नेगेटिव, प्लीज गिव एग्जांपल. अभी तो एग्जांपल दिया. जब हम कुछ भी उठाते हैं तो बॉडी पे लगने वाला जो फोर्स है वो दो फोर्स है, एक जो मैं लगा रहा हूँ, एक जो ग्रेविटी से लग रहा है, अर्थ से लग रहा है. सो द वर्क डन बाय माय फोर्स is positive, but the work which is done by mg is negative. What does positive work mean? It means that my force is trying to drive the body in that direction. Okay, it means the force is trying to drive the motion of the body in that direction. But what does negative work means? The force is trying to stop the body moving in that direction. The force does not like the body to move in a direction opposite to it. So force will always try to oppose that direction motion which is not in the direction of force. Okay, is that now clear? Yes. And as I said, I will give a better understanding. I will give a better understanding of positive, negative, and zero work in the next class when we will study energy because it is related to energy. Okay. Okay. Cool. Chalo, everyone. Yep. Let's go forward and let's solve a few questions. Question number one, as an example, please have a look. It says that a body of mass 5 kg is displaced through a distance of 4 meter under the acceleration of 3 meters per second square. So calculate the work. By definition, force into displacement is the work done. Now, theta not given. So if theta is not given, okay, if theta not given, then assume always, and always that theta is 0 degree. Okay, if in a question theta is not given, you will assume it is 0 degree. So we assume that it is equal to 0 degree, but force is also not given. So what? Can I calculate the force? Guys, can I calculate the force acting on the body? How do I do that? Can I write force as mass into acceleration? Yes. Good, easy. Mass of the body is 5. Acceleration of the body is given. Displacement is also given. Answer? Answer? But yeah, awesome. Okay. Yep. More question. For just for your recap, A dot B is AB cos theta. If A is given, B is given, theta is given. But if they are given in the given form, AX I cap, AY J cap, AZ K cap, then you write it as AX BX plus AY BY plus AZ BZ. I hope yaad aa gaya hoga. Okay, so let's do that. I have to calculate work, which is F dot S, which means X component multiplied, Y component multiplied, though there is no Z components, but mathematically that is there. Okay, so what is the X component of force? It is 5. What is the X component of displacement? It is 2. You will have to write it with plus and minus. You'll have to write it with the plus and minus which is there. So here we are fortunate that all the components are positive. Okay, otherwise if there would be any negative component, you'll have to put that negative component with that sign. So this is 2 and this is 3 and this part is 0. So this comes out to be 10 plus 6. What the answer, everyone? Easy peasy. Okay, got the answer. Okay, answer is 16 joules. One more. Now this time we have two forces acting on the body, and the body is getting displaced from say point P to point Q. So everyone, let's first try to find out the displacement vector. How do we get the displacement vector if the body is going from point P to point Q? Do you people remember displacement formula? x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. याद आया? जहाँ से distance formula बनता था. Good. So what is the vector? Displacement vector comes out to be 1. We are going from P to Q. Huh? So Q minus P. 1 minus 0. Final minus initial. Final position is Q. Initial position is P. So 1 minus 0 I cap, 1 minus 0 j cap, and 2 minus 1 k cap. Right? I cap plus j cap plus k cap. But here I have two forces, everyone. What do I do? I have two forces. I don't have one force acting on the body. So, very good. Everyone, if there are more than one forces acting on the body, there are two ways of looking at the situation. You can calculate the work done by both the forces individually. Means you can actually calculate work done as F1 dot S plus F2 dot S. Means work done by both the forces individually. You can do this. Or if you see this, I can take out S out of the situation like this and take the dot product with their resultant. Okay, getting it, everyone? So the resultant of these two forces can be found. So can you please find out F1 plus F2 with me and tell me what are we getting? दोनों vectors का resultant. 2 plus 1, 3 I cap. 3 minus 2. Directly लिखूँ ना, everyone? Are you all getting it? Okay. And minus 1 plus 2 is minus k cap. Please check, everyone. Are you all getting this force and displacement so far? Are we on the same page? Everybody? Perfect. So do the dot product for me now quickly. This is minus k plus 2. नहीं. अरे हाँ, plus आएगा. Correct. Plus आएगा. Thank you. Yes, plus आएगा. Plus k cap. So work done. Calculate quickly, everyone. So work done is F dot S. That looks like 3 plus 1 plus 1. That means 5 joules. Can't even write small j, because if I write small j, many of you will think it like j cap, and you will say that, sir, work has become a vector quantity all of a sudden. Okay, everyone, is that clear? This is F1 plus F2. Add the two forces. Find the resultant. Add their I caps, add their j caps, add their k caps. Arey, what second force here? क्या हो गया दिलराज? How we got second force? We have second force given in the question. This is second force. Do you know triangle of vector addition? What do we do in that? Can you add these two forces for me quickly and tell me what do you get? F1 and F2. Can you see now? Are you saying you are not able to see the screen only? So, in the question, you don't see F1 vector written here and F2 vector written here. What? You don't see 2 I cap plus 3 j cap minus k cap written on the screen. Not in my handwriting. The typed portion of the question. Can you read the question for me, please? Question. Please read the question. Did you just say 2 I cap plus 3 j cap constant force 5 I cap plus 2 j cap? You are still on the previous question then. You need to change the browser. Are you connected via mobile phone? Okay. Is that clear, everyone? we found the magnitude of the work here already, na? Okay. Let's not waste our time, everyone. Okay. Sir, we added directly. Yes, Harshan. But where did I need the magnitude of the vector? Is for work a vector quantity or a scalar quantity? Then why do I need it to be solved like a vector? What have I added? I've just multiplied this with this, this with this, this with this. How do you think 3 plus 1 plus 1 came? Just like that, of this force. You think that this has come from here? Then what do you mean by this thing written here? Does it look like written something in Chinese? That's what I'm asking. How we got 3 plus 1 plus 1? Then why did you say we just added 3 plus 1 plus 1? So what were we doing for previous two questions then? What do you think we did here? We are adding the multiplication of x components, y components, and z components. For more information, please refer to the chapter of vectors. Okay. Okay, everyone, let's go to the quiz quickly. And question in front of you. In this one, question says that a body of mass 20 kg is at rest. A force of 5 Newton is applied on it. You have to calculate the work done in the first second. In the first second, how much work is being done is what you have to find out. I have already wrote the hint for all of you. Try to find the acceleration, try to find out displacement, and then eventually the work done. Okay, everyone? Because for calculating displacement, you will require acceleration. So I'm going to give you all 90 seconds, and your time starts in 3, 2, and 1. Seconds remaining, everyone. That's good. Very nice. Okay, so basically, if I want to calculate work, I need the displacement along with the force. And because the angle is not given, I just need force and displacement to calculate my answer. The problem is force is given, but displacement is not given. So my entire efforts will go to find out displacement. And as you can see that the force acting on the body is constant. So definitely acceleration will also be constant, right? Because acceleration is nothing but force divided by mass. So if I calculate that, this is force divided by the mass comes out to be 1 by 4 meters per second square. So if this is constant, then I can always go back to my equation S is equal to ut plus half at square. Question has already told us that the body starts from rest. That simply means that the initial velocity is 0. So 0 plus half acceleration is 1 by 4 first second. That means this is the value that I was looking for. This is 1 by 8 meters. We already have the value of force. Let's calculate the value of the work done. That comes out to be force, that is 5. Displacement, that is 1 by 8. 5 by 8 joules is the correct answer. Okay. Okay, so this is the answer. Let's move on to the next question. Simple one for all of you. We have to calculate the work which is done by this force. Force is given. You have to find out that the body is going from this point to this point. Calculate the displacement and then simply find out the work done by taking the dot product. F dot S is what you have to calculate. Okay, giving you all 60 seconds for this one. Okay, and your time starts in 3, 2, and 1. Come on, people. Come on, come on, come on. Okay. This is an easy one. If you calculate the displacement in this question, the displacement will be final position minus initial. So that is 3 minus of minus 2. So 3 plus 2 I cap. This is x2 minus x1. Now y2 minus y1. That means 6 minus 1 j cap. And last would be minus 2 minus 3. This would be k cap. That means displacement is 5 I cap plus 5 j cap and minus 5 k cap. You already have the force. So let's multiply the x component. So 3 into 5 and minus 2 into 5 plus 4 into minus 5. So this is 15 minus 10 minus 20. That is 15 minus 30 or minus 15 joules is the answer. Okay, everyone? Correct answer is option B, minus 15 joules. Yes, Kushit? If the vectors are given in the form of I cap, J cap, and K cap, then you will apply triangle law. If the vectors magnitudes are given and the angle between the two vectors is given, that is when you will apply parallelograms law. And if you will go back to the notes of the class, I have clearly written it there in the notes also. In the notes of vectors. Never a question will tell you to solve a question by a particular method. They will not give you both the information. That will be the wastage of information. And if theoretically they do, then yes. Exactly. These are only two possible ways of giving the information. आज टाइम कम है, तुषित बच गए तुम. आज टाइम बहुत कम है, वरना बहुत लंबी रोस्टिंग हो जाती तुम्हारी अभी. बच गया तुषित. तो जब मैं प्रिपेयर करता था, when I used to prepare for JEE examination, you know, I was in this mathematics class and I used to be in a classroom of close to 300 students. In a class of 300 students, I used to study in a class of 300 students. And I still remember that day when I was sitting at the last bench. Not that I like to sit on the last bench. I reached class 5 minutes late because of that. I was at the last bench. Not 5 minutes late after the teacher started. 5 minutes after usually the gates are open. Yeah, 300 in offline class obviously. तभी किधर online class, तभी internet ही नहीं था. हाँ, internet था, but घर में नहीं था. So I still remember my mathematics teacher was teaching us inequalities in mathematics, and I guess this was the second session of equalities or third session probably. And this time I'm not understanding everything. I'm not even understanding anything actually. And I'm just trying to figure out by my own logic. Okay, this must be happening. This must be happening. Okay, this is happening. This is happening. I'm not getting anything. So finally, after half an hour or 45 minutes of the class, I raised my hand. That sir, I'm not getting anything that you are writing on the board. I'm not getting anything that you're writing on the board. I will never forget the roasting I got. I will never forget the roasting that I got that day. But no, ऐसा नहीं कि teacher did the roasting, the kind of roasting that I do. But the conclusion of that roasting was that you were not making a fool out of me, but you were making a fool out of yourself by not asking the doubt for last 2 sessions. So he obviously took 10 minutes to just roast me, and then finally he explained it to me that why this is happening, what he was explaining, and then I understood, and I can say that no, I definitely do not regret it. I definitely do not regret it because I understood what he explained. And my friend as a student was that it is better to be it is better to be insulted once now as a student instead of getting insulted as an engineer working somewhere, or as at this age if I do not know that thing, then that would be a bigger insult, right? So as a student, even today if I go in a classroom as a student, I will be a very I'll be a student who will not mind asking even the silliest of the doubt, but definitely I will be punctual. I will listen to everything which is said. Since that day I have been very clear that I am asking the doubts which are from that chapter then and there. I'm not taking it to after 4-5 sessions or after 4-5 classes or 4-5 chapters I'm asking the doubt. Okay, so maybe it will give you guys some ज्ञान, some wisdom. Okay. चलो बढ़िया. तो आज तुषित इसलिए बच गया क्योंकि आज टाइम कम है. Let's go. चलो everyone, let's go now. So everyone pay attention now. जब ये बेंच ये होगा ना, गपशप सेशन होगा या हमारा जो गाइडेंस सेशन है, तभी अपनी रोस्टिंग की स्टोरी सुनाना मुझे, ठीक है? Not now. So everyone, we have the other way of calculating work done, especially when force and displacement graph is given to you. An alternate method of calculating work done. If ever force and displacement graph is given to you, you can calculate the work done by finding the area bounded by the graph, or simple words by integrating as well. Okay, everyone. Do you guys know this thing already from 10th standard? That work done can be found as the area of force and displacement graph. You don't know this? That's okay. Right now, you don't have to focus on the integration part also, or whatever is written on the screen. You don't have to worry about that. Please do not worry about what is written on the screen from calculus point of view. But what I want you people to remember is that if you have a graph, this is the most important part. Okay, this is very, very important. The point which it is stating is very important. That the area above x-axis in any graph that you will solve to find the area of the graph in any question in physics, any question of physics, wherever you will find the area of a graph to find out a quantity. Basically, whenever you will integrate, which means finding the area of a graph. I hope you people remember. The area for a graph which is above x-axis will be treated positive. Area below x-axis will be treated negative. Can you people remember this point? Can you people remember this point? So please remember this. It will help us massively. It will help us massively. Okay. Yes. It is written. Whatever I have said is written on the screen. Okay. Area for a graph which is above x-axis is positive area. Area which is below x-axis is negative area. Okay. Let's see an example. Say if you have this graph in which the graph is obviously between force and displacement. It says that force and displacement graph is varying like this. Okay, and question is saying that we have to calculate the work done by this force as the block moves from origin, this is origin 0, 0 to 8 meters, when it moves on x-axis from 0 to 8 meters. Do I need the mass of the body? You will see that we will not need the mass of this body because we need to calculate the work done, which is basically force into displacement. Now, as you can see that force is not a constant, so you cannot directly just write down force into displacement into cos of theta. Why do I say that the force is not constant? You can see that the value of force is not always 10. It is becoming 0 also, it is becoming 5 also, it is becoming negative also. The force is becoming negative means force direction is also changing. Earlier the force was acting in this direction, the force also changed the direction, that's why it is negative. Whenever force is written negative, it basically means the direction is changed. Okay, and that is why the work becomes negative, because the force and displacement will now be at an angle which is 180 degree maybe. So everyone, we basically have a variable force and we want to calculate still the work done. So we'll basically make our life easy by finding the area. So we'll find out the area 1 of this trapezium, okay, and we'll find out the area 2, and here the area will be 0 obviously. This portion area is 0. So no work is done because force is 0. Fine, everybody? Hope it is clear to everyone. So when I try to calculate the work done, I will find out A1 and I will subtract A2 from it. Why will I subtract? one of the ways of doing it is writing a1 plus a2, but saying that a2 is negative. That is one way of saying it. Other way of saying it is that I will calculate all the areas numerically, and I will only put areas which are above x-axis positive, below x-axis areas will be written negative. Your choice. You can write it any which way. Answer has to come correct. Okay. Now, when you calculate the area of a trapezium is half into sum. Area of trapezium, you guys know that? Area of trapezium सबको पता है? So let's write it down. Half. Tell me the sum of parallel sides or parallel sides का values individually. Can you people tell me? It is 4 plus 2. Can I say that? 2 plus 4. What is the gap between them? It is 10. Okay. Though you are calculating the area, please don't write down meter square. Okay. Please do not write down meter square. This area is signifying a quantity which is work. Okay. Yes, you can split the trapezium into rectangle and triangle. Definitely you can do that. Now area of this triangle, half into the base of the triangle, that is 2, and the height of the triangle is 5. Please don't write minus 5. If you want to write it as minus 5, I have to write plus here. Okay. Getting my point? And then I will write minus 5 here. Totally your call. Good enough. 5 minus 5 is left, and here it is 3. So 30 minus 5, 25 joules is the answer that I'm getting. Are you all getting the same? Are you all getting the same? Good. बहुत बढ़िया. So that's the answer that we are all getting here. W positive, W negative. Okay, let's call it 1 and 2 also, because the works are not positive. Works are not equal. Good. So quiz question for all of you. Have a look, everyone. Now this is given to us. As you can see, the entire graph is above x-axis. There's nothing below x-axis. So entire work done will be positive, no negative work. All you have to do is calculate the area to find out the value of the work done. In the question, my suggestion, always read from which point to which point the area is to be calculated, or from which point to which point the body's work done is to be found. So fortunately in this question they are talking about 0 to 4. Sometimes they give you the entire graph, but they ask you only x equal to 0 to x equal to 3. In that case, if you just find out the entire area, your answer will come out to be wrong, because the question might not ask you about this triangle. Okay, so please be very alert when you are reading the question. You have to understand from which point to which point the body work done has been asked. Giving you all 60 seconds, and your time starts in 3, 2, and 1. Come on, people. Twenty seconds remaining. And the time is up. Okay, good. Okay, everyone, let's see. So area of this trapezium was to be found. If you don't know the area of the trapezium, you can find out the area of this triangle, and area of this rectangle also. But I prefer personally directly going by the area of trapezium. So you see that these are the two parallel sides, AB and OC. So half of AB plus OC multiplied by the gap between them. Let's call that gap to be D. Okay, so half of AB length, that is 3 minus 1, that is 2, and OC is 4, and D value is 5 newtons. So this comes out to be 8 by 2, that is 4. What just happened? Are you all getting the answer as 15 joules? तो मैंने क्या गड़बड़ किया? This is 2. Oh, 6 होता है यार, 6 होता है. This is 3 into 5. ठीक है, got it. Fine. ठीक है, now, so move on. Let's talk about work done by variable force. And this is, everyone, calculus alert. This is calculus alert, or I should say, integration alert. That means what? When I used to teach you guys calculus, I used to tell you about the horror stories of calculus. You know, horror stories सबको याद होंगी जो मैंने बताई थी. That they are not going to leave you for entire 11th and 12th standard. That horror story starts from here. Yes, officially the horror story starts from here. Surely theory तो बहुत easy है. This is integration. Okay. Yes. So after today's session, this is basically a reminder for all of you guys to go through the replays of the 2-3 sessions that I've taken on calculus. 2 or 3 sessions. If you are not very comfortable with vectors, also go for the revision of vectors also. Okay. So everyone, we have to find out the work done by a variable force, and precisely for situations like these, the integration technique will be helpful for us. Now again, I want your complete attention on the screen so that you understand what is happening in the question or in the situation. Not question, but the situation. So everybody, so far as I said, work done by the constant force can be written as force into displacement into cos of theta, and if theta is constant, any which way we can write down force into displacement. Life is very simple as long as the force is constant. But imagine a situation when your force here is 0, and by the time you reach it, or say maybe your force here is some, say, 10 Newton, and by the time you reach here, take the body here, the force acting on the body becomes 50 Newton. That means somewhere in between it became 25 Newton also. Somewhere here it became 35 Newton also. Somewhere here it became 20 Newton also. So now what do? Can I just take the average value of force and displacement and can I just take an average value of force as 10 plus 50 by 2, that comes out to be 30, and just work with it? No, it doesn't go with that way. Okay, practically the answer does not come out to be the same, and that is where you will start getting the feeling, because this kind of situation will happen in different chapters with different physical quantities, that the quantities will not be constant. Yes, if you remember, and if you don't, let me give you a quick 1 or 2 line example or revision of the part. I said that calculus is the chapter, or integration and differentiations are useful when there's a change in one quantity and there is a change in the other quantity which is depending on it. So the moment things starts changing, the moment when quantity starts changing, calculus jumps in. It starts playing its role, and for the first time, integration has come into existence. Actually, not for the first time, but for the part where it will play a big role, calculus and integration, especially integration, has now started coming into picture. So everyone, when we say work done by variable force we mean that now your force is not a constant. Which means what? Imagine a body on which the force is acting. The body is moving, the force is acting on it, but the force magnitude is changing as the body is moving. I will obviously give you practical examples of it after some time. But more importantly, the force will not be a constant. It will be a function of displacement. X is basically displacement. Okay, you remember this story? y equal to fx. This is what is happening. Y is a function of x. There in integration, when I taught you people this, y and x could be any two quantities. Here, right now, x is displacement. Okay, you can also write this entire thing as this. Let me give you the relatable expressions. Okay, I'm writing the displacement only. Okay, so if my force is a function of displacement, means what? You will know how force is changing with displacement. थोड़ा remind याद आएगा. Force could be algebraic function of s, force could be trigonometric function of s, force could be logarithmic function of s, force could be exponential function of s. These are the words which I used to use there also in integration. That if y is a function of x, function could be algebraic, function could be trigonometric, function could be exponential, function could be logarithmic. Any possibility. That question will tell you. Situation will tell you. But whenever that happens, you cannot proceed by considering that the force is constant, because force is not constant. So what do? You break the entire. Now what I'm saying is very important. Please pay attention to this part, everybody. So imagine that your body is being taken from position P to position Q. You will break its journey into small, infinite number of or n number of small displacements which are dx. Or here, because everything is written as x, so I'm going to make it s, so that we all don't get confused here. Okay. So what is happening here? This is my force, which is basically a function of x. This is or s. This is s equal to 0. This is s equal to s. This is small displacement ds. Means what I'm doing, when my body is say going from displacement 0 to 10 meters, I'm not dividing this entire displacement into 1 meter, 1 meter, 1 meter, 1 meter, and 1 meter 10 times. No, I'm not even talking about 1 meters. I'm not even talking about half meters gap. Okay, when the body is going from, just a second, everyone. I'm not talking about this, that this is a displacement where the body had moved by 10 meters. I'm not dividing this entire gap into 1 meters. I'm not dividing it into 0.5 meters. I'm not dividing it into 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. No, I'm dividing it into 1 micrometer, 1 micrometer, 1 micrometer, 1 micrometer, 1 micrometer. Means what? In this journey, there are very small displacements, which if I will even try to show it right now on the screen, the two lines that I have drawn will practically overlap with each other. These are the similar words which I used there in integration. You can watch the replays. Okay, why am I doing that is the real question. So imagine from the origin, you have randomly chosen a point which is at a distance x. Okay, and say that point is say P. Okay, and then from P, your body moves by amount displacement dx, small amount of displacement, to reach a point Q. Okay, my force is basically a function of x is given to me. Means my force is depending on displacement, that is x. Okay, everyone. So if I write the force at position P, the displacement is x. So I will be writing it as x plus, I will write it as f of x. Okay. To make it even more relatable, let me say that force is varying as x square plus 5. It is varying like this. So my force at position P is x square plus 5 when I put x equal to x. But at Q, the displacement has now become x plus dx square plus 5. Okay, you see that now force has changed because force is depending on x. So if x increases, force also increases, and that's what is visibly mathematically here in front of you. But if I move by 1 meter from x equal to 5 meters to x equal to 6 meters, if I go, then dx comes out to be 1 meter and my force becomes very different. It means what? If I choose dx gap to be very big, if I choose it to be 1 meter, half a meter, 1 centimeter, then my force from P to Q is actually very different. So what is the funda of choosing P and Q so small, so close to each other? Why dx has to be so small? Because everybody, if you remember, dx is that small gap that it is almost tending to 0. It is not 0, but it is tending to 0. Because of that, what happens? Your x plus dx value is almost equal to x value. Means if you start writing dx almost equal to 0, you can say that x plus dx is almost equal to x value. What benefit it gives me? What benefit it gives me is that if I write f of p as x square plus 5, I can say it is almost equal to f of q now. Or I should actually write f of q here, which I can write as x square plus 5, which is now almost equal to f of p. It might look like it is equal to f of p only, but I have assumed dx to be so small that it is almost tending to 0. Means practically, if you want to visualize it, when the body is moving between s equal to 0 to s equal to 10 meters, when I imagine the small displacement at ultra slow motion, imagine it. You are actually visualizing the body to be displacing by micrometers, something which will require like ultra pro max slow motion. In that small amount of displacement, I can say that, okay, my body has experienced almost a constant force because the displacement is negligible. So force almost remains a constant. And in that process, when the body is traveling by a very small amount of displacement, my dear students, the work which is done by the force is also very small. That is dw. Getting my point? Like that, when body moves, I calculate dw's for all the small amount of displacement, and I will eventually integrate. And integration means adding all these dw's. For the first time, I have given you the feel of integration from physics. Are you guys getting it? Are you guys getting the feel of it? I definitely know this is not 100% going to give you the clarity which I have. Definitely that will not get transcendent in one session. We will keep on doing it for chapter to chapter. We will do this from this chapter to next 5 chapters. I will show the application of integration in different quantities. But I want you people to watch the replay of this part, this screen, once again for 5 times at least. For 5 times. I want you people to see the replay of this portion, only this explanation. You will get a little bit better feel of it. And that feel is more important, trust me. Many times I'll focus on the quantity of it. Today the quality of it is very important. Okay? Good. So please listen to this part. Go through this part when you're watching the replay 5 times at least. You will get the idea. Okay? You can say that, Savai. You can say that. We are assuming like out of 10 crores, if we speak about 1 rupee, if you are say putting 1 rupee over each other, it's a very good analogy by the way. Okay, it's a very good analogy by the way. If I have to say stack, if I have to place rupees 1 coins over each other to create a stack of 1 crore rupees, 1 crore rupees. So if I'm moving, say after 1 lakh, I will place 1 more rupee. So it will be 1 lakh 1 rupee, but it will be almost equal to 1 lakh rupees. Are you getting the whole idea? We can almost consider it to be a constant number from 1 lakh to 1 lakh 1 rupees. Thank you for that example. Okay, everyone. Getting it? अरे बहुत possible explanations है, बहुत possible explanations हैं इसके. ठीक है, everyone? Yes, integration is basically trying to split a quantity which is changing which is changing, trying to talk about it almost becoming a constant when the things are changing by very small amount, and its impact on other quantity is what we want. The impact on the other quantity right now is on work. That impact is what we are interested in. So if you will go back to this slide, you might remember that we have seen this kind of graph. So this is force, this is displacement, and in this case, this is y-axis, this is x-axis. So earlier we talked about it in form of y and x. Now y is force, s is displacement. Okay, so we are splitting the entire area into small rectangles, and we are adding all those rectangles. The area of each rectangle is basically representing dw. This is equal to area. I'm hoping for that. Okay, and that is why what you see here is this what is happening. So I don't want you people to get confused. I'm just saying that this is what you're doing fundamentally. You are calculating all the small works, and you are calculating the entire work done when the force is changing. So you are actually calculating integration of dw's, and dw is already written earlier. dw is f into ds. Okay. You can write x also. In fact, many books you will find it written as s or x. Does not matter. What is important is that integration is being done. To give you a better clarity, I'll give you some examples here, everyone. So have a look at this example. How do we mathematically see it? A force is acting on the particle which is moving in x direction from origin to x equal to 5. And you see that the force which is acting on the body is 4x I cap plus 3y j cap. This is the force acting on the body. I will look at it as two forces acting on the body, F1 and F2. So if I calculate the work done by first force, the magnitude of first force is 4x. We know that the direction of force is I cap. So I'm just writing the magnitude of it. And if I write the second force, that is 3y, and it is acting along y direction. So everyone, if we look at the displacement of the body is happening from 0 to 5 meters. That means mathematically it is 5 j cap, or what is important, that displacement is along I cap direction. That is more important here, everyone. So as you can see that the force is not constant, so I cannot directly just multiply the displacement 5 with this force. I have to go by the method of integration. So I will write work done is integration of force into small amount of displacement along x direction. Why along x direction? Because that is the direction in which body is moving. How do I know that? Because the question is telling me that the body is moving on x direction. Okay, everyone. And now I will write the force which will be given to you in the form of displacement. As I said this here, that force will be given to you as a function of displacement. So see what is given to you in the given question, that your force is a function of x, and force is also given as a function of y also. Cool. So x is going from 0 to 5, 4x. Now the integration is the part which is super duper simple. Do you people remember the integration of x? 4 is a constant, obviously. Integration of x will be x square by 2 plus c also you should write, but in future you will realize writing c in a definite integration is useless. I might have said this earlier also. Writing integration with plus c is useless because that c gets cancelled. So 0 to 5 when we solve it, this is cancelling to 2x square. So 2 into 5 ka square plus c minus 0 plus c. Why 0? Because when I put x equal to 0, everything becomes 0. And c will get cancelled. I'm getting 25 into 2, 50 joules. So this is the work done by the first force. What will come out to be the work done by second force? Do I need to calculate that? Do you see that the second force is acting along j cap direction and the body is moving along x direction? So this is what will happen. You getting it? Work done by the y direction force will become 0 because of the angle. Okay. Hope it is clear. Thank you, everyone. Chalo, a question for all of you guys to try this now. Let's see if you guys are able to do this. We have a force which is given to us as 0.5x, which I'm writing as half of x. 0.5 is equal to half. Okay. Half of x plus 10 is the force. You want to calculate the work done, which you will write as f into dx. Okay. So you have to write down half of x plus 10 dx. Limits are given 0 to 2. Giving you all 60 seconds, and your time starts in 3, 2, and 1. 20 seconds remaining. Okay. Well done. Probably we have forgotten the rules of integration, so that's why I'm recommending you to recap it by watching the replays or going through the class notes. So integration of x is x square by 2, and only 10 is written. That means you can write it as integration of 10 dx, which is integration 10 coming out. Integration of dx is only x, so it is 10x. I'm not writing plus c because it gets cancelled anyway. And 0 to 2, so 0 will give me any which way 0 value, so only putting 2. So it is 1 by 4. 2 ka square will come out to be 4. 10 into 2, so this is 1 plus 20, 21 joules. Mathematics is something that I'm leaving for you guys to try here. Okay, everyone, just hold on a second. Okay. Hold on a second, everyone. Okay, so we got this, and this is the leaderboard for the day. Yes, I know we did not do many quizzes today, and usually when in mechanics this might happen many times. The introductory sessions are usually more explanatory. They require me to actually explain a lot of things, and that's what happened today. But any which way, those who are here on the leaderboard, congratulations to all of you people. We will definitely solve more problems. Okay, now this is the part which we did not do today. Okay, this is the part which we did not do today. Don't worry, Monish, I'll take the notes, no problem. Cool. So this part will start from here in the next class. We were supposed to go beyond 70 slides today, but we did not. That's totally fine. Sir, are you old or young? Wow, what a question here. Are you old or young? I'm 60 plus. I'm not less than 60. 1000 students are there, sir. Okay, so I will definitely be taking the doubts, but before that, yes, this is officially the end of the session. Officially the end of the session. Those who want to exit the session can do. Class teachers, once you are done finishing your doubts, you can also exit the session. ठीक है, चलो भाई अब आ जाओ. Siddharth, too early to think about that, but don't worry. Then when that situation comes, you will be able to solve for nth second also. Okay. Okay, so I know that you are in leaderboard today. That's why you are on cloud 9. Do you guys know that you have given an email ID on Vedantu when you joined Vedantu? Do you guys know that you have an email ID that you used to join? Not VK at Vedantu, your email ID. Either your email ID or your family email ID. One email ID you guys have given as a registered email ID. Okay. Do you ever go to the inbox of that email ID? Do you people go to the inbox of that email ID? What do you found there? What do you guys find there? Do you guys find the portion of your test syllabus there? You don't. If you don't find the details of upcoming test, please talk to your student academic mentor. Talk to your student academic mentor. Test syllabus, class changes, batch changes, complaints of the teachers, complaint of Suri sir is to be told on vk@vedantu.com. Okay. Jayant, trying to unmute you, not happening. Jayant, please rejoin the session. Rajkumar, doubts which are not belonging to this chapter, you will have to either wait till the end or you'll have to ask on the doubt app. Sir, friction based sums are taking a lot of time to solve. They are supposed to. Yes, they are supposed to take time. Okay. Sir, can you give me the brief summary of slide 50? I have given you detailed summary of slide number 50, and that is why I requested to watch the replay of this entire slide 5 times. Okay, Lakshya Pandey. Yes, Gauri Shankar, in this chapter, I will take the question where there will be mass in the string also. Okay. What is the need of impulse if force can be calculated? There is no need of anything in this universe. Okay. If the question will ask us to calculate, we will calculate. If the question will give you the value of impulse, you will use it. आ जाओ भाई, किसी ने तो इस सेशन से रिलेटेड डाउट पूछा फाइनली. Yes, Monish. Nah, yes, you are. Tell me now. So, do you understand what does it mean when we write 4 I cap? What does it mean? That means I have to draw it like this. This is 4 Newton force. What do we understand by 3 J cap? Correct? Correct? Will they both try to take the body in the same direction? They will try to take the body in the same direction. And what? Forget about the resultant. Individually, will 3 Newton force try to take the body along x-axis? Yes. Listen to my questions correctly, okay? And carefully before you answer. What is the direction in which 3 Newton wants the body to go? And what is the direction in which 4 Newton wants the body to go? And in which direction your body is moving? So what do you think is happening with this body? Which force is able to drive the body in that direction? If the body is going along x-axis, out of these two forces, which of the forces is able to drive the body? Which of them is able to do the work? Let's not believe it. Let's just calculate it. So 4x is the force, right? Displacement is s. Angle between them is 0 degrees. Can I say that? Right? This is work by 1. And I will have to actually integrate because force is not constant. But that is the secondary part right now. Second thing is force, which is 3. So it is not constant right now. 3y it is, right? So even if it would be constant, I will write it as 3y and the displacement. And the more important part is this angle that I'm writing. Cos of how much? Okay. You understand the reason also? Okay. Okay. So what then will come out to be? W2 will come out to be 0, right? That is what is written here. And the work done by the other force is non-zero. Have I cleared your doubt? If force is given like this, then it is definitely, if it is not, then definitely we will calculate the work done by both the forces. We have actually calculated the work done by both the forces, but the second one came out to be 0. We will follow the same process. Only the angle may not be 0. May not be 90 degrees. Okay. Yes, Anish. But your work done will be negative. Definitely, but that will be negative. Yeah, there will be work done by you. Means assuming that what you are saying is this. This is the car. This is you. You are trying to apply the force on the car in this direction. The car is going in this direction, right? This is what is your visualization, right? Then work done by you is negative, even if the car is moving in the right direction. So who's doing the positive work? Force applied by the engine on the car. That is why engine is an important part of the car, right? Done? Sir, area under VT graph gives displacement, whose dimensions is meter, but area is product of two dimensions. Then how is it possible mathematically? कब से इस बैच में हूँ? तो जब कैलकुलस पढ़ा रहा था तो क्लास में सो रहे थे, तो ये जो डाउट पूछा है उसका आंसर वहाँ है ऑलरेडी, नहीं बता सकता क्योंकि वो बहुत लंबी कहानी है, थोड़ा सा बताया आज, तो इतनी मेहनत तो करो, ये 10 स्टैंडर्ड नहीं है, दिस इज जेईई प्रिपरेशन, यहाँ खुद से भी मेहनत करनी पड़ेगी, क्या नहीं मिल रहा है, मैंने जो पढ़ाया मैं वो लेक्चर्स देखने के लिए बोल रहा हूँ, हाँ तो वो लेक्चर्स देखने हैं और अगली बार देख के आओगे तब बात करेंगे। हाँ समझ बताओ, रुक जाओ। यस सिचुएशन magnitude wise, yeah, practically it is change in momentum, but it is the force which will be not always called impulsive force. When will I say force is an impulsive force? When that force acts for a very small duration of time. Means what? If you try to think of impulse as the force, then you are not thinking it in the right direction. It is the impulse as a quantity which is equal to the change in momentum. It is force which is impulsive or not impulsive. Have you heard this statement or people saying that this is an impulsive decision? Have you ever heard this conversation dialogue that this is an impulsive decision? You're not. Say you are in a market, you are with your parents, and you just look at a cricket bat and you want to buy it. You ask your father, not cricket bat. You are looking at say when you are in 5th standard, when you did not even know how to use the computer, and at that point of time you would ask your father to buy your computer. That would be an impulsive ask. Impulsive ask. Why? Because right now that is something which is extremely short-lived. What you would be reacting to would be a very short time duration thought process. So whenever time duration is very small, you talk about things to be impulsive. So it is not impulse which is force, it is force which is impulsive if it is acting for a very short duration of time. And that is what we saw, that when the force was acting for a very short duration of time, that is 0.01 seconds, it turned out to be 1,000 times bigger than the norm. So it is impact. F2 will not be called an impulsive force accurately, because impulse is like this. So people in the first situation of the car are experiencing a force which is giving them this impulse, or rather I should say an impact. But in the second situation, when 5 seconds are being taken to bring a car to rest, definitely people inside are very safe. They are not experiencing any kind of jerk or shock or impact. Getting? Cool. So if we are in a lift, then with respect to a person outside, will there be work? Wait, yeah, I don't prefer video unmuting you guys. Yes, Sadiq. If we are in a lift, then with respect to a person outside, will there be a work? First, you will have to define the force. Which force are you talking about to check whether it is doing a work or not? Because work is being done by a force. So if you are in the lift and somebody is watching you from outside, which force are you trying to focus on? Your weight or his weight? Okay, so situation will depend upon which force. Definitely, that is why. Aman, I think I've unmuted you once already, so I'll have to give chance to others. Rajkumar, you'll be the next one. Yes, Amrita. Then that is one of the possibilities when work is zero. I have explained that part, yes. Maybe, may not be. If a body is at rest, it will stay at rest. If a body is moving, it will continue to move until unless you apply a force. So there might be a body which is already moving. But we are focusing upon this force, which is acting at an angle of 90 degrees. The work done by it is zero. Like if I speak about this situation, let the graphic image come. You see this animation? Done now? So this is basically a car. I'll try to show it to you. No, that's okay. So if this is the car, and I said that the weight of the car is not going to do any work. The work done by the car is zero. Work done by the weight of the car is zero. Right? So your question is, but then why car is moving? Is that your question? Because it is being driven by some other force. We are not talking about the work done by that force. We are talking about the force which is acting perpendicular to it. The work by that force is zero. Yes. Seriously, that was told by your teacher. Actually, they might want to tell you that if you have something on your head and you are walking, when by lifting they might mean when you have something on your head and you walk horizontally. then work done by you is 0, because, or rather work done by your weight is 0. I will actually talk about this situation in the next class. A very interesting situation. Cool situation. Mathematically that might look like 0, but actually non-zero at muscular level. When it is on your head and you're standing, 0 work. To take it from ground to your head, you have already done the work. From ground to your head, work is done. Yes. Which graph? This one or this one? I think you're talking about this one. Useless quantity. Useless, not even quantity. Just like finding the area of displacement time graph gives you nothing. It is mathematically possible, but it gives you nothing. In the chapter of calculus, I've said this a number of times. So yes, velocity time graph, we do both area and this slope both. So physics will tell us. Today I calculated slope. Not even a single place we calculated slope today. We did not calculate slope anywhere today. You can go through the session once again. You'll find out accordingly. Okay. Okay. Bye bye. कहाँ गया राजकुमार? Yes, राजकुमार. कैसे पॉसिबल है? बिल्कुल ऐसे पॉसिबल है. प्रैक्टिकली दिख रहा है सामने पॉसिबल है. और मैंने कम से कम 5 बार ये बात बोली कि इसका और अच्छा एक्सप्लेनेशन दूंगा अगले सेशन में कि ये नेगेटिव वर्क का फिजिकली मतलब क्या है या इस वैल्यू का नेगेटिव आने का मतलब क्या है. ये मैं एक्सप्लेन करूंगा अगले सेशन में. बोलो. y is equal to sin 1 minus 2x the whole cube. क्यों करना ये क्वेश्चन? पहला क्वेश्चन तो ये है. समझिए. ये तुम्हें कहाँ मिला? अदर वे राउंड. फिजिक्स के तत्व में y इक्वल टू साइन 1 माइनस 2x का क्यूब. और ये होल क्यूब है या 1 माइनस 2x का क्यूब है? ठीक है. तो पहले तो 1 माइनस 2x का डिफरेंशिएशन कर दो. बताओ. 2 या माइनस 2. अब भूल जाओ कि ब्रैकेट में कुछ लिखा है. सिर्फ ब्रैकेट टू दी पावर 3 का डिफरेंशिएशन. पावर 3 रहेगी तो पावर कुछ रहेगी या नहीं? मतलब 2. ओके. अब साइन का डिफरेंशिएशन. ये आंसर. इसको पता सिंप्लीफाई कर लेना. इन दोनों को मल्टीप्लाई कर लेना. ठीक है. पहली बात तो ये क्वेश्चन हमारे लिए यूजलेस है फिजिक्स में, पर ये क्योंकि तत्व में है तो तुम बोल रहे हो तो मैं ट्रस्ट कर रहा हूँ कि है तत्व में. और ये वो क्वेश्चन है जिसमें एक नहीं, दो नहीं, 3 फंक्शन है. इसीलिए 3 अलग अलग डिफरेंशिएशन हुए हैं. तो पहले 1 माइनस 2x का डिफरेंशिएशन, फिर 1 माइनस 2x की जो पावर है उसका डिफरेंशिएशन, फिर इसको कुछ अज्यूम कर लिया और साइन का डिफरेंशिएशन. दैट इज व्हाई. ठीक है. बोलो सुधीर. माइक से थोड़ा 10 किलोमीटर और दूर जाके बात करो. माइक से और 10 किलोमीटर दूर जाके बात करो मुझसे. ऐसा लग रहा है कि माइक एक कॉर्नर में है घर में और तुम दूसरे कॉर्नर में बैठे हो. थोड़े से पास आ गए हो. हाँ हाँ ठीक है. बोलो. यू आर ज्वाइनिंग और यू हैव ज्वाइंड. नहीं तो बोलो यार, उतनी मेहनत मत करो. बोलो. बोलो. ये क्वेश्चन है. हाँ देखो देखो. था एक मिनट को. हाँ, एक मिनट. आई थिंक ये वाला क्या. हाँ हाँ बिल्कुल. हाँ. गुड. हाँ शिवांश. यस बोलो. डिपेंड करता है सिचुएशन पे. ये बॉड मास का रूल नहीं है कोई. बॉड मास का रूल फॉलो नहीं करते. हाँ. अगर एक ब्लॉक है और उसको क्या किया है हॉरिजॉन्टली. हाँ एक एंड फिक्स, मतलब ये वाला फिक्स है ना. मतलब पहले जो रोप है वो लूज है अगर मैं समझ रहा हूँ तो. ठीक है ठीक है ठीक है ठीक है. हाँ हाँ ठीक है. समझ गया, मैं समझ गया. तुम्हारा सिचुएशन ये है कि एक ब्लॉक है जिसको हमने एक स्ट्रिंग से कनेक्ट करके रखा हुआ है और ये ग्राफ सरफेस पे रखा भी हुआ है और अब मैं उसे यहाँ से पुल करना चाहता हूँ. तो ऑब्वियसली सिचुएशन में तो पहले फ्रिक्शन आएगा, क्योंकि जब तक स्ट्रिंग पूरी खिंच नहीं जाएगी तब तक टेंशन डेवलप होगा नहीं, या रादर तब तक टेंशन वो चीज नहीं कर पाएगा जो हम लोग स्टडी करते हैं. ठीक है. हम्म, हम्म, इसका एक्सेलरेशन का ग्राफ दोनों का या इंडिविजुअली किसी एक का? हाँ, तो बेसिकली क्या होगा, जो फंक्शन दिया हुआ था क्या? अच्छा, f इज इक्वल टू दिया हुआ है। तो जैसे जैसे, हाँ वो समझ गया, ठीक है। एक्सेलरेशन जो है दोनों के लिए देखो एक सर्टेन टाइम तक तो डेफिनेटली एक्सेलरेशन सेम रहेगा, इनफैक्ट जीरो से स्टार्ट होगा एक सर्टेन टाइम तक के लिए। तो दोनों के एक्सेलरेशन के ग्राफ जो भी बनेंगे वो स्टार्ट होंगे जीरो से। तो मान लो ऐसा कुछ है, एक सर्टेन टाइम तक जीरो ही रहेगा। उसके बाद में तुम्हें दोनों के इंडिविजुअल फ्री बॉडी डायग्राम्स पे फोकस करना पड़ेगा, ठीक है। अगर M2 की बात करूँ, ऑब्वियसली पहले M2 का फ्री बॉडी डायग्राम स्टडी होगा, जिसपे F फोर्स लग रहा है। इस पे यहाँ से लगने लगेगा पहले स्टैटिक फ्रिक्शन, इसका F1 बोल देते हैं उसे, और यहाँ से भी लगेगा F2, ठीक है। पॉइंट इज, ये वाली बॉडी तब तक मूव नहीं करेगी जब तक कैपिटल F का वैल्यू F1 प्लस F2 दोनों ही फोर्सेस से ओवरकम नहीं कर जाता, तब तक वो बॉडी मूव नहीं करने वाली, ओके। उसके बाद में M1 का अगर फ्री बॉडी डायग्राम देखते हैं तो M1 ऑब्वियसली तब मूव करेगा जब M2 मूव करना शुरू कर चुका होगा। तो बेसिकली स्टार्टिंग में सिचुएशन कुछ ऐसी आएगी कि M1 और M2 विल ट्राई टू मूव टुगेदर, और उसके बाद में M1 और M2 के दोनों के अलग अलग ये आ जाएंगे, एक्सेलरेशन आ जाएंगे। तो वो ग्राफ देख के अकॉर्डिंगली विल टेक अ कॉल कि भाई किस तरह का स्लोप अकॉर्डिंगली जाने वाला है। तो एक्सेलरेशन विल बी अ फंक्शन ऑफ, हाँ ठीक है। कांस्टेंट रहेगा एक्सेलरेशन उसका, हाँ M1 का एक्सेलरेशन ग्राउंड के साथ कांस्टेंट हो जाएगा, बिकॉज़ उस पे लगने वाला फोर्स जो है वो कांस्टेंट हो जाएगा। उसका जो काइनेटिक फ्रिक्शन है जो उसे ड्राइव कर रहा है वो कांस्टेंट है, हाँ, तो उसका एक्सेलरेशन डेफिनेटली A1 हो जाएगा कांस्टेंट, और A2 जो है वो कंटिन्यू बढ़ता जाएगा। वो इसलिए होगा क्योंकि जब तक ये दोनों साथ में मूव कर रहे हैं तो यहाँ पे दोनों लिमिटिंग फ्रिक्शन वाली सिचुएशन रहेगी। तो सडनली फोर्स पहले थोड़ा कम होगा उसके ऊपर, और फिर उसके बाद में वो कांस्टेंट होगा। तो मे बी यहाँ से ऐसा जाएगा वो, और स्लोप चेंज हो जाएगा, स्लोप चेंज हो जाएगा, मतलब किसी और एंगल पे चला जाएगा, ऐसा चला जाएगा क्योंकि उसको लगने वाला फोर्स डिक्रीज हो गया। एक्सेलरेशन बढ़ेगा, हाँ थोड़ा सा गैप आएगा, एक्सेलरेशन की वैल्यू में थोड़ा सा गैप आएगा, क्योंकि वो एक्सेलरेशन जो है मतलब वो ग्राफ के वैल्यूज के हिसाब से कॉल ले लोगे तुम। बट व्हाट इज इंपॉर्टेंट हियर कि ये वाला जो जोन है यहाँ पे इन दोनों के बीच में लगने वाला फोर्स लिमिटिंग रहेगा, और ये वो पॉइंट है जहाँ पे एक्सटर्नल फोर्स ने इस लिमिटिंग फोर्स को भी ओवरकम कर लिया। अब M1 और M2 के बीच में रिलेटिव मोशन हो जाएगा, इस पॉइंट के बाद में दोनों अलग अलग जाने लगेंगे, और उसमें भी M1 जो है वो कांस्टेंट एक्सेलरेशन से, और M2 जो है एक्सेलरेशन कंटीन्यूअसली टाइम के साथ बढ़ता ही चला जाएगा, ठीक है। नहीं बहुत पुराने क्वेश्चन होगा, मतलब बहुत पुराने से मतलब पिछले लास्ट 5 साल में तो डेफिनेटली नहीं होगा ये भाई, अब नहीं आते ये सवाल। गुड, एंजॉय, चलो। तो भाई कहाँ गया यार, ये सुधीर से बात करनी थी। हाँ सुधीर, बोलो बोलो, अभी थोड़ी देर पहले तुमसे बात कर रहा था क्या मैं? हाँ बोलो। एक ब्लॉक है एम, कौन से चैप्टर का डाउट है पहले ये भी बता दो। हाँ ब्लॉक है, आगे बता दो। हाँ हाँ, व्हाट इज मेकिंग एन एंगल थीटा विद द बॉल, कुछ ऐसा है क्या? यहाँ है ऐसा, ये एंगल थीटा दिया हुआ है। हाँ, वो क्या कर रहा है? प्लेन, मतलब ऐसा, नहीं समझ पा रहा हूँ मैं, ऐसा सही बनाया है गलत है ये? तो कैसे कनेक्ट होगा? ऐसे? हाँ, ये फिक्स्ड है या नहीं ये वाला पार्ट? अच्छा ये बॉडी है, तुम प्लेन बोले तो मैं बॉल समझ गया उसको। एक मिनट रुको भाई, तो ये ऐसे कहीं रखी हुई है क्या? हाँ ठीक है। कौन ये? एक मिनट, ये भी काउंट रखिए। हाँ, और ये बॉडी इधर मूव कर रही है विद वेलोसिटी v, और क्या पूछा है? तो इसका एक एक्सप्लेनेशन ये होता है कि अगर मैं इसकी वेलोसिटी को, मान लो ये वेलोसिटी v है, तो p q r लेंथ ऑफ द स्ट्रिंग की अगर बात करें, तो जितना मान लो ये x अमाउंट इधर गया, तो qp जो है वो x अमाउंट इंक्रीज हो गया, तो यहाँ से rq x अमाउंट कम होना पड़ेगा। तो बेसिकली ये जो x अमाउंट का चेंज है वो ब्लॉक की वेलोसिटी तो है ही, वो इतने पोर्शन ऑफ स्ट्रिंग और इस पोर्शन ऑफ स्ट्रिंग की वेलोसिटी भी वही है, मतलब रेट एट विच द स्ट्रिंग इज मूविंग हियर इज बेसिकली v। r जो पॉइंट है वो v वेलोसिटी से q की तरफ जाने की कोशिश कर रहा है, ठीक है। तो इस वेलोसिटी का जो वैल्यू है वो इसके ऊपर डिपेंड करता है v1 पे, या v1 जो है वो उस वेलोसिटी पे डिपेंड करता है। तो इसलिए कि आर क्यू और क्यू पी मिला के जो टोटल लेंथ ऑफ द स्ट्रिंग बनती है उसको कांस्टेंट रखना है। तो ये जो v1 cos थीटा है, जो v1 cos थीटा है वो एक्चुअली v के बराबर होगा, तभी पूरी लेंथ ऑफ द स्ट्रिंग कांस्टेंट रह पाएगी। जो ये वेलोसिटी है भाई, तुम जो ब्लॉक है वन, ब्लॉक वन की वेलोसिटी जो तुम v1 कंसीडर कर रहे हो वो एक्चुअली पॉइंट आर की भी तो वेलोसिटी की तरह दिखती है, पॉइंट आर ब्लॉक से कनेक्टेड है ना। तो आर को v1 वेलोसिटी से मैं हॉरिजॉन्टली लेके जा रहा हूँ, लेकिन आर का एक कंस्ट्रेंट है कि उसका जो लेंथ है क्यू के साथ में, वो अगर मान लो आगे जाके पी से कनेक्ट होता है और पूरा लेंथ आर क्यू पी कांस्टेंट रखना जरूरी है, तो कैन आई से दैट पी जितना आगे जाएगा और या कितनी जितनी वेलोसिटी से मूव करेगा उतना ही आर को इस डायरेक्शन में वेलोसिटी से मूव करना पड़ेगा। तो वो तभी पॉसिबल है जब ये वाली वेलोसिटी का कॉस कंपोनेंट जो है v1 cos थीटा और v दोनों सेम हो, उसका वो कंपोनेंट है वेलोसिटी का, इसलिए ठीक है। डन, ओके। यस हर्षिता, मतलब ये किस सिचुएशन के पॉइंट ऑफ व्यू से बात हो रही है, मेरे को क्लियर करो, कौन से चैप्टर के पॉइंट ऑफ व्यू से बात हो रही है? अच्छा, फ्रिक्शन वाले क्वेश्चन की बात हो रही है, ठीक है। वो एक ही डायरेक्शन में जा रहे हैं, हाँ ठीक है, मतलब एक्चुअली असम्पशन था कि दोनों का एक्सेलरेशन सेम है, मतलब और क्या कैलकुलेट करने बोल रहा है वो क्वेश्चन? हमें क्या फाइंड आउट करना है, उसके बिना में कैसे आंसर करूँ, कि हम क्या करेंगे? आर यू गेटिंग माय प्रॉब्लम? हम्म। हम्म। जा रहे हैं। हाँ। हर्षिता आवाज नहीं आ रही? हेलो, तरीके जी ब्लॉक कर क्या? हर्षिता तुम जो क्वेश्चन फ्रेम कर रही हो वो पहली बात तो फ्रेम नहीं कर रही हो प्रॉपर्ली। वी हैव टू फाइंड आउट समथिंग, व्हाट डू यू वांट मी टू फाइंड आउट? क्या पता लगाऊं? वो क्वेश्चन जो है उसमें जो ऑब्जेक्ट्स हैं उनके ऊपर फोर्स लग रहा है नहीं लग रहा है तो भी वो अप्रोच सही है, वो अप्रोच के साथ ही जाएंगे हम लोग हमेशा। अप्रोच वही रहेगी कि हम अज्यूम करेंगे कि दोनों सेम डायरेक्शन में जा रहे हैं, और बाद में प्रूव कर नेचुरली प्रूव हो जाएगा न्यूमेरिकल वैल्यू के साथ में कि दोनों ऑब्जेक्ट का एक्सेलरेशन का वैल्यू क्या आ रहा है। ठीक है। हम्म, ये वाला क्वेश्चन। हाँ, अब क्वेश्चन क्या बोलना चाह रहे हैं ये बताओ। पढ़ो, तुम्हारे सामने लिखा है क्वेश्चन, पढ़ो, मन में पढ़ो, पढ़ने के बाद मुझे क्वेश्चन बताना। ओके श्वेता, बताए। बाय दिनेश। बाय समझ। हर्षिता मैं तुम्हारी भेज देता हूँ। हाँ। हम्म। 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 नहीं कर रहा, नहीं कर रहा या नहीं करना चाहिए। तो मेरा क्वेश्चन ये है कि पी फोर्स नहीं लगाने से पहले क्या हो रहा होगा? अगर मैंने फोर्स पी लगाया ही नहीं, जो फोर्स पी को लगाने के लिए बोल रहा है क्वेश्चन में, अगर मैं ना लगाऊं तो क्या होगा? ऐसा सोचो, एक स्लोप वाली रोड है ना अशिता, एक स्लोप वाली रोड है और उस पर एक कार खड़ी है, खड़ी रहना चाह रही है पर रह नहीं पा रही। पीछे से कुछ लोग हैं जो उसको पुल कर रहे हैं, या कोई गाड़ी के आगे खड़ा है जो उसको धक्का दे रहा है ताकि वो ना गिरे या नीचे ना आए। ये सिचुएशन इसको इमेजिन कर पा रहे हो? ऐसा कुछ हो रहा है यहाँ पे, ठीक है। तो हो ये रहा है कि ये बॉडी जो है इसमें 3 न्यूटन का फोर्स ऑलरेडी नीचे की तरफ लग रहा है, शायद वो कार के इंजन की वजह से लग रहा है, किसी भी वजह से लग रहा है, ठीक है। ये एम जी साइन थीटा जो है वो हमेशा इंक्लाइन प्लेन के नीचे लगता है, यस या नो बोलते जाना। एम जी कॉस थीटा उसको पेंडिकुलर लगता है, नॉर्मल उसको बैलेंस करता है, राइट। अगर ये क्वेश्चन में फ्रिक्शन जीरो होता तो ये फोर्स मैं कभी भी नहीं लेता, तब तो कभी भी बॉडी रुक ही नहीं सकती थी, नीचे आती नीचे से। पर अभी क्योंकि फ्रिक्शन है तो मैं चेक करना चाहता हूँ कि बिना वो फोर्स लगाए बाहर से क्या ये बॉडी रुक सकती थी। तो हमने वो चेक किया कि भाई फ्रिक्शन का जो वैल्यू है, लिमिटिंग फ्रिक्शन, वो म्यू एम जी कॉस थीटा के बराबर आता है। ये बात समझ में आती है? तो ये कैलकुलेट करके देखते हैं तो मालूम पड़ता है कि यार वो तो एम जी साइन थीटा से छोटा वैल्यू है। जब तुम चेक करोगे म्यू एम जी कॉस थीटा निकालोगे, म्यू का वैल्यू 0.6 डालोगे तो वैल्यू एम जी साइन थीटा से भी कम आएगी। उससे ये मालूम पड़ेगा कि आप जो फोर्स नीचे लाना चाहते हैं बॉडी को, वो ऊपर रोकने वाले फोर्स से ज्यादा स्ट्रॉन्ग है, तो क्या बॉडी नीचे आनी चाहिए? जो बॉडी पे नीचे रखने वाले फोर्स है, नीचे से मतलब इंक्लाइन पे नीचे रखने वाले फोर्स है, वो ज्यादा स्ट्रॉन्ग है उसके ऊपर रोक के रखने वाले फोर्स से, तो क्या बॉडी नीचे आनी चाहिए? तो इसको रोकने के लिए कितना फोर्स ऊपर और लगाना पड़ेगा मिनिमम, वो क्वेश्चन हमसे पता लगवाने बोल रहा है। क्या क्वेश्चन समझ में आया अभी? तो हमने वो फोर्स कैलकुलेट किया है कि हमने मान लिया कि ये फोर्स हमने यहाँ लगाया है ऊपर की तरफ ताकि बॉडी रुकी रहे। तो क्या मैं बोल सकता हूँ कि पी और फ्रिक्शन दोनों मिलकर अगर नीचे लगने वाले फोर्सेस को बैलेंस कर लेंगे तो हाँ बॉडी रुक जाएगी। बस तो इसके बाद मैथ्स लगाई, मैथ्स में कुछ डाउट है तो पूछो, ये समझ जाओगे। ठीक है चलो, ओके, गुड नाइट। आर बी डन फाइनली? संकेत भयान हो या चले गए? बाय अर्षिता। संकेत है या चला गया? चला गया यार, ठीक है। ठीक है, तो एवरीवन मिलते हैं नेक्स्ट क्लास में ऑन वेडनेसडे। फाइन एवरीबॉडी, गुड नाइट, बाय बाय, बाय एवरीवन, चलो साइनिंग ऑफ।